Hi guys, welcome back to our lesson. So we are still looking at exploring different functions. Now we are going to look at an exponential function and try to see what it is all about, what is the general equation, how do we change it, and when we change it, what happens, right? So let's just look at that together. Now, an exponential function will be a function of the form f of x is equals to ab to the exponent of x plus q, where the a, the b, and the q are constants, right? And then the exponential function has one asymptote. Now, if you remember correctly, whenever we look at a hyperbolic function, we say it has two asymptotes, but with this one, it only has one, which is normally the horizontal asymptote. So this only has the horizontal asymptote with it, which is the q value. Now consider the graph, or the equation rather, f of x is equals to 2 to the x. If my x is minus 1, this is going to be 2 to the exponent of negative 1, which is 1 over 2. And then when my x is 0, it will be 2 to the exponent of 0, which is equals to 1. Then when my x is 1, it will be 2 to the exponent of 1 is equals to just 2. Now, if I want to plot this, right, as I said, to plot this, my negative 1 goes with a half, so it will be somewhere there, which is a positive half. And then my 0 goes with 1, so it will be somewhere there. My 1 goes with 2, it will be somewhere there. And then roughly when you join the points, it will then be something of that sort, right? So you can already see that the horizontal asymptote, it means that it can never cross there, right? It can never cross the x-axis. So for it not to cross the x-axis, it means y is equals to 0 there. So y can never be 0, right? Although it is confusing when I say y is equal to, it means the equation y equal to 0 is where the graph cannot cross in simple terms. That's what we mean. And then the x-intercept is calculated rather by letting y equal to 0. So you can see, since there are no values for x where 2 to the exponent of x must give me 0, the conclusion will be y equal to 0 is the asymptote, right? So this is the asymptote of this particular graph. And also, it does not have the x-intercept. So in simple terms, there is no x-intercept. Now, another type of an exponential graph will be where the b value is a fraction, right, between 0 and 1. Same concept. If I substitute minus 1 there, this will give me 2. If I substitute minus 1 by the 0 by the x there, it will give me 1. And then lastly, if I substitute 1, it will then give me 1 over 2. Just so that you can see, it's 1 over 2 to the exponent of negative 1. This will give you 2. 1 over 2 to the exponent of 0. This will give you 1. And then 1 over 2 to the exponent of just positive 1. This will give you 1 over 2. So that's where I get my values. But you guys can always just press your calculator and it will give you those answers. To plot this as well, the negative 1 is the one that goes with a 2, so it is up there. The 0 goes with the 1, it is somewhere on the y-axis there, and then the 1 goes with a half, so it will be somewhere here. And then when you join this, it will look something of this nature here. All right, still, you can still see that this is not crossing the x-axis, so it means it does not have the x-intercept. Now, as I said, the x-intercept, we know, is calculated by letting the y be 0. But there are no real values for x for this thing to be valid. There is no way that you can write 0 as a base of a half so that you can equate the exponents, because that's what the rule of exponents is. So the conclusion will be y equal to 0 is the asymptote, right? Asymptote. And then the other important thing is that there is no x-intercept. Is there y-intercept? Yes, because this graph is crossing through the y-axis there, right? So only the horizontal axis that the graph is not crossing through. Now, when we analyze the shape of an exponential graph, what does the a value do and what does the q value do, right? So firstly, the a shows us what we call the vertical stretch of the graph, right? Vertical stretch meaning it becoming a bit stretched vertically, right? And not really enlarged in terms of horizontally, no, stretched vertically. And then the value of q represents the shift of the graph up or down, right? Shifting means you are moving the graph. So if I say this is the mother graph, right? If I say this is the mother graph, and then I shift it upwards. When I shift it upwards, it will still be the same, but just a bit higher than it. Or shift it downwards, it will still be the same thing, but a bit down there. So although my graphs might not be drawn to scale, but that's really what I mean. And then the value of b in the equation represents the shape and the steepness of the graph. Shape, why? Let's go back quickly to what we've had, right? Remember when it was positive, when it was a value that is greater than 1, which was 2, the graph was moving from left to right and it was going up, right? But as soon as it became a half, which was between 0 and 1, it was still moving from left to right, but now it was going downwards, right? So that's what the b value does. Now, to be particular with this, if b is greater than 0, we say that the graph moves upwards from left to right as the x value increases. In simple terms, guys, as you are moving from left to right with the x, right? If you are moving from left to right, you're starting from the negative side and going to the positive side. So clearly the x value is increasing. And this graph you're saying is moving upwards, so it will then be something of that nature like that. But as soon as it becomes between the 0 and the 1, and why are we only focusing on between 0 and 1 and not less than 0? It's because the b value can never be a negative. There is no way that you will say your graph, the b value, which is the base of the exponent, is a negative. From your lessons about exponents and your knowledge of exponents, there is no way. I promise if you do that, it means you are very smart, but in a very wrong way, because you cannot have a base of an exponent as a negative. So please just make sure you understand that. So it can only be between 0 and 1. As you saw, it was a half, or it can be a quarter, or it can be 3/4, as long as it is just between 0 and the 1 there. And this will then say that the graph moves downwards from left to right. As what? As the x value is increasing. So graphically, this will look something like this. We said it is moving down, so it is like that. And although it has arrows on the end points of it, someone might say, how do I know that it is moving down or up? We are judging from left to right. So if I move from here and go to the right, you can see the graph is going down. If I move from here to that side, you can see the graph is going up. So that's how we are gauging it, even though it still has arrows at the end point. And then lastly, as the value of b decreases, the graph gets steeper. Now, let me tell you, we then normally call this first one, when b is greater than 1, we call this the increasing function, right? This is called the increasing function, which you need to know, because at times the question might be, is this increasing or decreasing? But with this one, this is a decreasing function. This is decreasing. And then why are we saying increasing and decreasing? Is because we are mainly looking at the y value, right? So as x is increasing, the x value are increasing, the y value is also increasing here. You can see, because it is going up, right? This is also increasing. And then with this one, as x is increasing, the y value is decreasing. So how do you judge that the graph is increasing or decreasing? You look at the y value. If the y value is increasing as the x increases, then it's an increasing function. Vice versa, if the y value is decreasing, x is always increasing because you are always moving from left to right. That will then be a decreasing function. Guys, let's take a quick ad break. When I come back, we are going to look at how do you then try to look at the functions together in one plane. How do you explore them as one plane and two different functions? Please stay tuned.